Okay, I don't know what is happening. I don't know why I can't see this stuff. Let me start this again. Okay.
So we shouldn't fill the attendance for second lecture, right?
No, you should not. You should not. Attendance is on. Fill in the attendance form for the first session. Okay, here it is. Okay, let's look at some of the open something. For example, this one is, yeah. Stream insertion operator is overloaded as a friend function, friend global function. Can anybody tell me why we do have to overload the stream insertion and extraction as a global function instead of member function? We have to do it. Okay? Yes.
Because we don't want to call it like dots and the function operator.
We can't call it, right? Right.
We can, but
We can't, no.
no, we can't.
So, anybody? Why do we have to implement the stream insertion and extraction as a global function? There is no way we can implement them as a member function. Yes?
Because we want to use it with another, other object.
Yeah, what is the other object?
I don't know. We can use it with our class object and
Well, I mean, my object is like money, right? I like to make this possible. I like to make this see out your amount. Your amount is a money object. I have to overload this as a global function, not as a member function. In fact, I can't do it. As a member function, I can't. Why? Because as a member function, if I like to do it, I have to write cout dot operator stream insertion your amount, right? Whose object is cout? Is that our object? No. Somebody else wrote the class for cout. I don't know the type of it. Cout is an object of somebody else's class. Am I going to go into that class and add a member function? No, I am not allowed to, right? So I need to overload this. I need to overload this as a global function. There is no way. Since I am overloading it as a global function, and sometimes I need to access the data members, private data members, then I am going to make it friend. That's why we always do that, okay? So these two things, O stream and IS, OS stream and IS stream, are the really types of, this is the type of the cout object, OS stream, and this is the type of the cin object, IS stream, okay? And we say that I am going to take, on the left side of this operator, I am going to take one OS stream as a reference. On the right, I am going to take a constant money. I promise I am not going to modify it. Then after I am done, I am going to return an OS stream, the same thing that I have taken as the parameter, so that it can be done in a cascaded fashion like this, okay? So this one here, this expression will return the cout object itself. So if it returns cout object itself, then this expression will work. Okay, so that's the main reason why we are doing it. And remember what we said, we like to be proper in terms of object-oriented programming rules, but in this case we have to write this operator overloading as a global function. Okay, there is no other way. This is not for efficiency. This is not for convenience, because this class is not ours, right? This class is not ours. Okay, that's one thing. The other thing they ask you to learn is, this is number 5. Let's look at the number 6. This is the index operator. Let's look at the number 7. Yeah, well, this is the index operator again. Let's look at, well, what happened to my index operators? Where are my index operators? Yeah, here it is. Okay. So to overload the plus plus operator for prefix version and the postfix version, I use this notation. Remember, when you look at this, this is a part of the class, right, in pair. I mean, this is a unary operator, right, plus plus. Doesn't matter it doesn't matter it is a prefix or postfix. It's a unary operator. So this is nice, but how about this one? It takes an integer. This is a dummy integer just to distinguish between these two signatures, okay? If I don't have this integer here, signature-wise, there is no difference between line 9 and 10, okay? So how does the compiler know that I am overloading the prefix operator or the postfix operator, right? That's why we put this dummy integer in here. It looks like a parameter. Well, it's a parameter, but we don't pass that parameter. It is just a parameter without any names, and we overload the postfix version. Okay, so I mean, you were supposed to learn these yesterday. Let's try to write something today. I like you to write. Let's say this is our main function. Okay, let's say this is our main function. Okay, our class would be my string class and S1 and S2. Okay, we are going to represent strings. Our strings will be, okay, regular strings, but at most 100 characters. Okay, so you can store at most 100 characters in it, or let's be more, okay, generous and make it 1,000 character, at most 1,000 characters, but it is fixed. And I like to do stuff. Oh, maybe I should do this. Yeah. I can initialize it with. I can initialize with my favorite string like that. In this case, I did not initialize with anything. How about this? I can initialize it with. No, I am not going to do this. Okay, good. Okay, so this one, then I am going to do this. S1, sorry, cout. I'm going to print it on the screen. And maybe I can do stuff like S1, the second character. Oh, okay, S1 doesn't have anything in it. Okay, let's make this S2. And S2, 0, maybe let's make it a character, let's say Q. This one works too. What else do you want? Oh, okay, so maybe I can do this too. As my string S3 is S2 plus, yeah, df, or maybe, okay, this is good too, okay, and cout S3. Okay, so this is what I like to do. Write a class, first do the header, and then after the header, implement the class, and write this main first, okay? I mean, if I were you, I would write this main first. Do you want me to send this to, oh, well, you are going to write it yourself, okay? I can post it to the Teams and you can get it there, but I mean, it is easy to type it up. I'm going to keep it here, so no problems. And write your class definition first, and then implement it. But my suggestion is write the class definition, implement your functions in a way that, okay, there is no implementation, your program just compiles, okay? So you don't have any problems with your class definition, and then you start implementing it. So what are you going to implement? You are going to implement some constructors, stream insertion operator, index operator, add operator, and etc. Okay, let's start. So it is 8:50. Okay, I am going to get your results by 8:20 or maybe 15, and we are going to look at a few of your solutions for this one. Okay. Maybe stop recording. Why am I recording? Yeah.